You are staring at your friend. The conversation has stopped. Your mouth is slightly open and you haven't blinked in 4 seconds. You are completely paralyzed because the name of that one actor, the guy from that movie with the aliens, the one who was also in that dark detective show, has suddenly, inexplicably vanished from your brain. You can see his face perfectly. You know exactly what his jawline looks like. You know what he sounds like when he yells. But the word is simply gone. Your friend is staring back at you, waiting. The silence in the room is stretching. You snap your fingers. You look up at the ceiling as if the name is written on the plaster. You can feel the word. It is right there. But your brain hasn't lost the name. In fact, it is doing the exact opposite. It is actively, aggressively, and intentionally working to block you from saying it. Right now, there are roughly 86 billion neurons firing inside your skull. Trillions of synapses are trading electrical and chemical signals at hundreds of miles per hour, processing everything from your heartbeat to the temperature of the room. And at this exact second, a tiny, specialized cluster of those neurons has basically taken your own memory hostage. Why does your own mind intentionally sabotage you precisely when you need it the most? Why does the most sophisticated computational system in the known universe suddenly build a solid brick wall right in front of the one piece of data you are absolutely desperate to retrieve? Why does your brain treat a simple actor's name as a threat that must be contained? By the time this video ends, you will understand why forcing yourself to remember is the absolute worst thing you can do. You will see the bizarre, counterintuitive glitch in your biological operating system that makes this cognitive kidnapping happen, and you will realize that your mind is not a tool you control, but a battlefield you barely survive. But to understand this glitch, you have to look at what your brain is actually doing behind the scenes while you agonize over that one missing word. For over a century, psychologists thought memory worked exactly like a giant metal filing cabinet. Back in the late 1800s, early memory researchers like Hermann Ebbinghaus believed that forgetting was simply a matter of passive decay. They assumed memories were physical impressions stamped into the soft tissue of your brain, filed away in neat chronological order. And just like an old, fragile photograph left out in the bright sun, they assumed that data just slowly evaporated from your brain cells over time. If you couldn't remember a name, a date, or a place, the scientific consensus was brutal but simple. The ink had faded, the paper had crumbled, the file was permanently destroyed and swept out of the cabinet. For decades, the entire field of psychology accepted this as absolute truth. But the tip of the tongue phenomenon shattered that theory completely, because in that agonizing, frustrating moment of blanking on a word, you know the memory is not fading. You know it hasn't decayed. You know the first letter. You know exactly how many syllables it has. You can literally feel the physical shape of the word resting right at the edge of your vocal cords, pressing against the inside of your teeth. In 1966, researchers Roger Brown and David McNeil at Harvard University proved that this feeling is not just a psychological illusion. They designed a study specifically to break the human memory retrieval system in real time. They gathered subjects in a room, read them dictionary definitions of obscure words like nepotism, sampan, or ambergris, and waited for the subjects to freeze. They were hunting for that exact microsecond where the brain stalls out. When people hit that exact state of knowing a word but failing to speak it, the results defied everything science thought it knew about forgetting. The subjects could accurately guess the number of syllables 57% of the time. They could accurately identify the starting letter. They could rapidly list other words that sounded exactly like the one they were missing. They would groan, clench their fists, and sweat as the word hovered just out of reach. The data was not missing. It was trapped. The 1966 Harvard study confirmed that the folder is right there, hovering perfectly intact in the architecture of your mind. But there is a biological bouncer standing directly in front of the drawer, crossing its arms, absolutely refusing to let you open it. Your memory is not a hard drive. It does not use neat alphabetical directories. It is a messy, chaotic, constantly shifting network of overlapping associations. When you look for a word, your brain does not execute a clean linear search query. Instead, it sends a violent burst of electrical pulses down a complex web of specific neural pathways. In neuroscience, this is called spreading activation. Think of it like pouring a bucket of water onto a cracked, dry sidewalk. The water doesn't go in a straight line. It branches out, finding the paths of least resistance, filling every single crack it touches. Most of the time, this flood of electricity hits the exact right neurons, and you speak the name without a second thought. But sometimes, the electricity takes a slightly wrong turn. It accidentally activates a similar, completely wrong word first. Maybe it's a word that sounds similar. Maybe it's a co-star from the exact same movie. Maybe it's just a word you used 5 minutes ago that is still glowing with residual energy. And this is where the biological sabotage begins. This wrong word doesn't just sit there quietly. It acts like a massive neurological roadblock. In cognitive psychology, this mechanism is known as the blocking hypothesis. Some researchers even call it the ugly sister effect, because the wrong word steps in front of the one you actually want, demanding all your attention. The blocking hypothesis states that the more you focus on the missing word, the more you accidentally pump energy into the pathway of the wrong word. Every time you strain your mind, you are fortifying the wrong neural connection. You are making the wrong word stronger, brighter, and louder inside your head. You are feeding the interference. And by doing that, you are actively burying the real answer even deeper into the dark. This means your frustration is literally the mechanism keeping you from remembering. Your intense mental effort is the exact tool your brain uses to block the retrieval. You do this every time you desperately snap your fingers, squeeze your eyes shut, and try to force the word out. You think you are breaking the door down to get to the memory, but you are actually just locking the door from the inside. You are pouring solid concrete over the exact trapdoor you are actively trying to open, but for decades. We didn't know exactly how aggressive this mental roadblock was. We couldn't see the structural damage. We didn't understand the sheer biological violence happening inside your skull when you forget a name. Until researchers put frustrated, agonizing people inside an fMRI machine to watch the sabotage happen in real time. Dr. Anat Merrill, a cognitive neuroscientist at Harvard University and MIT, wanted to see what a brain actually looks like when it is desperately trying to scratch a mental itch. She didn't want to rely on self-reported feelings or behavioral guesses. She wanted to look at the raw, bleeding edge of human cognition. In 2001, she and her team designed an experiment to map the precise neurological geography of human frustration. Imagine lying perfectly still inside a massive, humming magnetic tube. The space is tight. The air is cold. The machine clicks, bangs, and whirs violently around your head, generating a magnetic field tens of thousands of times stronger than the Earth's. Directly above your eyes, a small screen flashes trivia questions. These are not just any questions. They are specifically engineered, weaponized prompts designed to trigger that agonizing "I know it, but I can't say it" feeling. Questions about capitals of obscure countries, names of outdated navigation instruments, faces of forgotten politicians. The researchers watched the oxygenated blood flow inside the subject's brains second by second. They mapped the electrical spikes. They tracked the metabolic demand. They waited for the subjects to hit that mental wall. When the participants successfully answered a question, their standard memory centers lit up quietly and efficiently, exactly as expected. When they had absolutely no idea what the answer was, the brain stayed relatively quiet, accepting the defeat without a fight. But when they hit the tip of the tongue state, when they knew the word but couldn't reach it, the scanners captured something deeply unsettling. Their brains did not show a lack of activity. They showed a massive, localized explosion. A very specific region called the anterior cingulate cortex lit up like a Christmas tree. The anterior cingulate cortex is not a memory storage unit. It is your brain's internal conflict resolution center. It is the exact same neural region that activates when you feel intense physical pain. It is the region that fires when you make a severe, highly consequential mistake in public. It is the biological siren that goes off when your mind detects two opposing forces fighting for total dominance over your body. The brain was literally fighting a brutal, energetic war with itself. Published in the prestigious journal Neuron in 2001, Dr. Merrill's study proved that the tip of the tongue state is not an absence of memory. It is a high-stakes, high-energy neural conflict. It is a violent clash between the word you desperately want and the noisy, overwhelming static your brain is actively generating to find it. Your cognitive system is registering your attempt to remember as a structural threat. It is treating your own memory like an invading virus. And once you realize your brain is actually designed to fight itself under pressure, it changes everything about how you interact with your own thoughts. Understanding that memory is an active, competitive, and highly volatile reconstruction completely destroyed the old filing cabinet myth forever. Your mind is not a passive librarian handing you neatly organized folders. It is an arena. It is a brutal battlefield where millions of neurons compete viciously for your conscious attention every single second. And in learning this, we lost something deeply comforting. We lost the illusion that our memories are perfect, stable recordings waiting to be effortlessly played back on demand. We lost the arrogant assumption that our minds are entirely logical, but most importantly, we lost the comforting belief that our brains are completely under our own control. But in exchange for that loss, we gained something incredibly powerful. We gained the ultimate cognitive hack. We gained the biological justification for letting go, because if conscious, aggressive effort is the very thing creating the neural blockade, the absolute only way to break the blockade is to remove the effort. You cannot force your way through a wall that is built out of your own force. By stepping away, you change the biochemical environment of your brain. By stopping the frantic mental search, you cut off the electricity to the wrong pathway. By forcing yourself to think about something completely different, what you had for lunch, the temperature of the room, a random song on the radio, you actively starve the wrong word of its energy. You let the incorrect, noisy neural connections cool down to room temperature, and once the static fades, the interference disappears. The right word, which was waiting there quietly the entire time, effortlessly bubbles up to the surface of your consciousness. Usually when you are in the shower or driving or doing absolutely nothing. The hardest you ever work to remember something is exactly what guarantees you will forget it. Surrender is literally the only way to win the battle against your own biology. The next time you're stuck mid-sentence, staring blankly at your friend, feeling that familiar, terrifying spike of panic, you will know the truth. You will know that pushing harder is just digging the hole deeper into the ground. You will know that the only way to find the missing piece is to surrender the search entirely. You have to walk away from the door so your brain can finally unlock it, which brings up a much darker, much more unsettling question about who is actually in charge inside your head. Your brain isn't a highly advanced computer that occasionally glitches under heavy processing load. It is a chaotic, uncontrollable ecosystem where thoughts literally battle for your conscious attention. It is an environment where your own desires can be weaponized against you. If your own neurons can build a wall to block you from accessing your own memories, it forces a massive shift in how you view yourself. If your conscious, deliberate will is not enough to retrieve a single simple word from the architecture of your own mind, it makes you wonder about everything else you think you control. Are you the one actually driving this biological machine, or are you just along for the ride? Are you the sovereign master of your thoughts, or just a hostage to the invisible biology locked inside your skull? When you finally remember that actor's name 3 hours later, was it you who remembered it, or did your brain simply decide you were finally allowed to know? What is the one word, name, or movie title that your brain constantly holds hostage from you? The things you can't remember aren't lost. They're just waiting for you to stop looking for them.